PolarDB Hitless scaling is powered by a 3-layer decoupling cloud-native architecture. The CPU, memory, and storage decoupling enables memory fusion, lock fusion and transaction fusion, and advanced enterprise-class capabilities built on these latest technologies. Hitless scaling allows you to do both vertical and horizontal scaling, switch over and upgrade your PolarDB instance without any degradation of service, thus not interrupting your mission-critical systems. In the top half of the screen, we use the same sysbench command to perform sequential read and write operations on both PolarDB instances to simulate actual business traffic. The bottom half of the screen shows the database clients for each of the 2 PolarDB instances. As you can see, we have prepared a STIS database for each of the 2 PolarDB instances, and this database has a table T1. In addition, there is only one row of data on table T1 with initial value as before test. We then use the begin command to start a transaction on both instances, and change the value of the initial data to start test for subsequent testing, in order to see if the transaction is affected during switchover. Keep the sysbench traffic simulation running, and go to the PolarDB console to perform a manually forced switchover. Generally speaking, the impact of manual forced switchover is similar to that of HA failover, version upgrades, instance specification change and other maintenance operations. So we can literally know the effect of other similar operations through this demo. After switching the primary node, we can see that on the upper left, the TPS of PolarDB instance A drops by more than 10 seconds, and even reports connection interruption. While on the upper right, the TPS of PolarDB instance B drops by only 5 seconds. And for PolarDB instance A, the failed connections stop 10 seconds after switchover, which means it returned to normal. As for PolarDB instance B, it only took 5 seconds to be back to normal, shorter than the PolarDB instance A. Later, when the TPS became normal, querying data from table T1 after a transaction that didn't commit, and we can easily notice that the long connection on PolarDB instance A is lost, while the opposite is true on the PolarDB instance B. The connection on PolarDB instance B is holding up well, so the response returns as expected. Then we're trying to query data from table T1 on PolarDB instance A. Another error occurs with a responsive before test instead of start test, indicating that the transaction has been completely lost. However, when we perform an update on PolarDB instance B afterwards, and then query data from table T1, the result responds normally. This means the transaction on PolarDB instance B is not affected at all. By demonstrating a forced switchover of 2 PolarDB instances, we can see that the hitless scaling of PolarDB with Hot Replica feature enabled provides higher availability and service guarantees, helping enterprise users achieve business continuity.